Hi everyone, Ian here from crackmaths and welcome to this question and answer section on all the questions for topic 78, which is prime numbers. So let's begin. Question 1 is circle all the prime numbers in this list. So we have 11, 15, 17, 18, 19 and 21. Well, I know that 11 is a prime number because it can't be divided by anything else. 15 can be divided by 3 and 5, so that's not a prime number. 17 is prime. 18 can also be divided by 3, so we can rule that one out. 19 is prime, and 21 can also be divided by 3. So the prime numbers in this list are 11, 17, and 19. Okay, next question we have, question 2, which is the next prime number after 29. So the next prime number after 29 is 31. 31 is not in any times table, so that is the next prime number. 30 isn't a prime number because it can be divided by 2. Question 3. True or false? 51 is prime because it cannot be divided by 2, 3, 5 or 7. Well, looking at that statement, I believe that statement is false because I think 51 can be divided by 3. If you're wondering how I know this, I'm not I'm not someone that just knows all the numbers that are divisible by 3, but I do know a divisibility check for numbers that are divisible by 3. And that is if you can add up the digits of a number. So in this case, if we take 5 add 1 and they equal a number that is in the 3 times table, in this case 6, then that number 51 will be divisible by 3, and we can check that here by doing 51, put 3 here. So 3's into 5 go once with a remainder of 2. 3's into 21 go 7 times. So here we go, 51 divided by 3 is 17. So 51 is definitely not prime because it can be divided by 3. So this is a false statement. Right, question 4. Write down 3 prime numbers that add up to 30. Oof, wow, okay, so there's probably quite a lot of combinations for this, but let me think. What I'm going to do is I'm going to start with 23 because that's quite a nice high number. So that's going to get, I'm 7 now away from 30. Now, 7 can be made by 2 and 5, which are both prime numbers. So here we go, I could have 23, add 2, add 5, and that will equal 30. And each of these 3 numbers is prime. So there we go. There's multiple ways of solving that question, I'm sure. Right, let's have a look at question 5. So question 5 says, which of these numbers are prime? Well, I know that 9 isn't prime because it's in the 3 times table. 11 is prime. You can't divide 11 by anything. 13 is prime. You can't divide 13 by anything. 16 is an even number. So all the even numbers except 2 are divisible by 2. So therefore, the only even prime number is 2. So 16, I know, is not a prime number because it's even. And 19, yes, 19 is a prime number. So 11, 13, and 19 are my answers there. Okay, question 6. Which of these pairs both contain prime numbers? Okay, so we've got 23 and 27. Okay, 27 isn't a prime number because 27 is 3 times 9. 41 and 43. Okay, I think they're prime, you know. I think they're both prime. But let's rule it out by process of elimination. 55 and 59. Well, 55 is 5 times 11. Okay, so the pair with the 2 prime numbers is going to be B. Okay, let's have a look at question 7. So question 7 says, 91 looks like a prime number. Show why it isn't. Okay, right. So it's a large odd number. Instantly, I can see that it's not divisible by 3 because 9 add 1 equals 10 and 10 isn't divisible by 3. It's not divisible by 5. I don't know if it's divisible by 7, but there's only one way to find out, which is to do 91 divided by 7. So here we go. Put 91 here, 7 here, 7's into 9, go once with a remainder of 2, 7's into 21, go 3 times. So here we go, 91 isn't prime because 7 times 13 equals 91. And of course, if this appears on a calculator paper, you're more than welcome to use your calculator. In fact, let me get my calculator out. So here we go, let's do a quick test of that. We've got 7 times 13, and let's see if this definitely equals that. Yep, 7 times 13 is 91. Lovely. Right, let's have a look at question 8. Question 8 says, find a prime number between 40 and 50. So I remember from a previous question that they were showing us that 41 is a prime number, so I'm going to go for 41. I believe we could also have, for this case, 43 as well, but either of those are both correct. Is 47 a prime number? It might be as well, actually. Let's Let's have a quick look. 47. 47 divided by, well, it's not divisible by 3, it's not divisible by 5, it's not divisible by 7, it's not divisible by 11. Is it divisible by 13? I don't think so. Here we go. No. What about the next prime number, 17? Divided by 17? Nope, definitely not. Yeah, there we go. So anyway, 47 to me looks like it's not a prime. It is a prime number as well. We can try a few more. Divided by 47 divided by 23? Nope. And then that's half of it anyway. 23 is just over half. So once you've gone to halfway, you know that you're in the clear. So yep, 47 could also be an acceptable answer for that question. Question 9. Pick two prime numbers over 4 and under 10. Multiply them together. What do you get? Okay, so the two prime numbers over 4 and under 10 are going to be 5 and 7. So 5 times 7 equals 35. There we go. That's the answer to that question there. Right, question 10 from the practice questions, and then we'll move on to the scenario ones. So this question says, what is the difference between the largest and the smallest prime number from the list? Okay, well, the largest prime number, 35 is not a prime number, 25 is not a prime number, 37 is a prime number. So the largest prime number is 37. So we're going to take away from that the smallest prime number, which is 2. So the difference between the largest prime number and the smallest prime number will be 37 take away 2, which will equal 35. Okay, right. So let's have a look at question 1 from the scenario section. And this says, a school is organising chairs into equal rows. There are 29 chairs. Explain why the chairs cannot be arranged into a complete rectangle with more than one row. Well, the answer is 29 is prime, so can only be made up by 1 times 29. Okay, there we go. Right. Question 2. A fruit seller has 53 apples and wants to pack them into equal bags with no apples left over. Show why each bag must contain 1 apple or 53 apples. Okay, only way to divide 53 is by 1, as 53 is a prime number. Okay, question 3. A code lock uses a 2-digit prime number. Write down 2 possible numbers that could be used. Okay, I'm just going to go for 11 and 13. Here we go. Question 4. A train runs every 17 days and a swimmer trains every 19 days. Explain why they will not train on the same day for a very long time. Okay, well the answer is because they're both prime numbers, so their lowest common multiple is going to be achieved by 17 times 19. That's something about prime numbers. They do not have any real lowest common multiples with different numbers. That isn't just themselves times by that, because there's just nothing you can cancel down. So what should we write? Both prime, LCM equals 17 times 19. And we can get the calculator out and find out what that is as well. 323. So it takes 323 days before they both train on the same day. Okay, question 5. A bus company has 97 buses. The manager wants to split them equally between garages. Show why this is only possible if there is one garage or 97 garages. Okay, so 97 is prime, so it cannot be divided by anything. So they said show it, so maybe they want us to prove that. So we could have 97 divided by 3. So first of all, we can say 97 is odd, so it can't be divided by anything even. So that rules out all the even numbers. And then we can just do so 97 divided by 3 is, we now can't, it's not going to be divisible by anything in the 3 times table. 97 divided by 5, won't work. 97 divided by 7 is a possibility. 13.8. We could have 97 divided by 13. Okay, we kind of just have to work through the prime numbers really until you get to a certain point. Next one would be 97. Oh, we could do divide by 11, but we know that doesn't work, so that'd have to be 99. Divided by 17 maybe, that could be the one. Okay, right, and now we're getting answers that are lower than what we've dealt with. So because we've got 5, we've already tested the 5 and we've tested 7. So we know there's nothing lower than 7 that is divisible by. So therefore, we've actually shown it. So we can stop there because that is enough information. We've shown that we can't divide 97 by anything because we've already tested all the numbers up to 17, and now we're getting answers that are lower than 17, so therefore there's not going to be anything that we compare it. So even if the number gets bigger, say for example 23, there's not going to be a number that 23 is going to be multiplied by, because it's not going to be 3, it's not going to be 4, it's not going to be 5, so therefore those numbers won't work either. So there we go, we've actually shown it by doing these calculations here. Question 6. A shop sells packs of pencils. The pack size must be a prime number between 10 and 20. Write down all the possible pack sizes. Okay, so this just requires us to know the prime numbers between 10 and 20, which are 11, 13, 17, and 19. Question 7. A number is chosen at random between 1 and 30. What is the probability that it is prime? Give your answer as a fraction in its simplest form. Okay, so here we've got all the prime numbers between 1 and 30. So we've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers, so 10 out of 30 is the probability. And you might spot that that simplifies down to 1 over 3. Question 8. A football tournament has 23 teams. Each team must play every other team once. Explain why there cannot be an equal number of teams in each group. Okay, 23 is prime, so cannot be split into an equal number of groups. And then we can add 23 times 1 equals 23. Only way to make 23. Question 9. Question 9 says here, a cinema has 19 seats in a row. The manager wants to split the row into equal sections of seats. Explain why this cannot be done unless each block has 1 or 19 seats, and that is because 19 is a prime number, so can only be split by 1 and itself. Right, lastly, question 10. We've got a teacher writes a 2-digit number on the board. It is a prime number greater than 40, but less than 50. What number did the teacher write? Well, there's options. It's these prime numbers between 40 and 50. So we could have 41, 43, or 47. Right, and there we go. That's all the questions on prime numbers answered. If you want any more work on this, I've got a tutorial that explains it in greater depth. But other than that, that's that really. So anyway, I hope that's all okay. And see you in another tutorial or question and answer section. Okay, bye.